Hello everybody, we are going to be going over our 7.4 notes, which are over quadratic transformations. If you have been with us since the first semester of algebra, we've actually already done transformations before, but we did linear transformations, so today is going to be quadratic transformations. The great thing about quadratic transformations is they are pretty similar to linear transformations. There's kind of just one main difference that we're going to discuss today, so because of that, I'm going to go through the notes pretty quickly, and if you need a little bit more of an in-depth like notes video, I would maybe go back and reference the linear transformations video back in Unit 4. Okay, so as a reminder, a translation is when your graph shift up, down, left, or right. Because we're doing quadratic transformations, I specified a parabola, but this is where you go up, down, left, or right. When you translate a line or a parabola, it does not affect how wide your parabola is, and it does not change the direction of opening for your parabola. A reflection is when your parabola will flip over the x-axis or the y-axis. Oops, why did I do that? This does not affect the width of the parabola, it just affects the direction of opening. And then a dilation is when your parabola becomes either narrower or wider. This may also be a vertical / horizontal stretch or compression. The STAR test has done this two different ways. Sometimes they will say narrower or wider. Sometimes they will say it is a compression or a stretch. This right here is the only thing that's different between a linear transformation and a quadratic transformation. Linear transformations, the graph cannot get wider or narrower. Your graph becomes either steeper or it becomes less steep. So with linear transformations, we said our graphs got steeper or less steep. With quadratic transformations, our graphs will either get wider or narrower. Okay, so I'm going to remind you about vertical translations. That is when your graph shifts up or down. So if you see something like this, because this number back here is not inside of the parentheses and it is to the right of your x, this is how we know that this is going to be up or down. And whatever sign is in front of your number tells you the direction. So positive means that we're going up. So this is up 3. And this one over here would be down 2. Just like with linear transformations. Horizontal translations is where your graphs shift left and right. And this, remember, when it's in the parentheses, but to the right of x, this is your right or left direction. And this is always the opposite of what you see. So because you see this negative, you might think that you're going left, but in reality, you're going to the right. So anytime that you see a minus sign, you're going to the right. So this would be a right 4. And then over here, you have a plus sign in the middle, which means that you're going to go to the left. So this is to the left 1. All right, with reflections, these reflections are actually the exact same from linear reflections. When you have a negative to the left of your x, that means that you are going to have a reflection. A negative directly in front of x means that you have a y-axis reflection. And then if you have a negative to the left of x, but it's all the way in front of f, this is when you have an x-axis reflection. Remember, if you need more information, you should go back and look at the notes in Unit 4 when we did linear transformations. Okay, dilations are where your graph does not have a steepness anymore. It's either going to get narrower or wider. And we will see the numbers for this in the same spot that we saw numbers for steeper or less steep. But again, with quadratic equations, that's not a thing. They can only get wider or narrower. So what we're going to do is we are going to jump on over to Desmos so I can show you what this looks like on a graph. Okay, so x squared is the parent function for quadratics. So when you look at this, you should say this is the parent function for a parabola, and any change that I make to the numbers in front of my equation will determine the width of my parabola. So I'm actually going to change this first equation. I'm going to change this to f of x equals x squared. It's still red. Okay, now in our notes, the very first example we were given is g of x, and that equaled 5 times our f of x. So when you think of a number that is greater than 1, because in the parent function, the number in front of your x squared value is always a 1. If you change that 1 to either something bigger than 1 or something smaller than the 1, that is how we know that our parabola is going to be changing widths. If we put a 5 in front, with linear functions, that would mean that your graph became steeper, but we don't have that option with parabolas. So if you look at this picture here, my red graph is my original, but then my blue graph is my transformed graph. So instead of my graph getting wider, which we may think happens because that number is bigger than 1, our graph actually becomes narrower. The bigger the number, the more narrow it gets. So let's do 15, and that's really, really narrow. Now let's try a number that is smaller than 1, but isn't negative, because negatives deal with reflections, they don't deal with width. So let's do 2/5. So if I change my 1 in front of x squared to 2/5, my graph actually got wider. So when you have a number that is greater than 1, 5, 2, even 15, 1,000, whatever you want, your graph is actually going to get narrower, and the bigger the number, the more narrow it gets. And then if you change to a number that's smaller than 1 but greater than 0, so not a negative, just a number less than 1, your graph is going to get wider. Let's do something crazy. Let's do like 1/20. Boom, that is a very wide parabola. I had to sneeze, so if I sneeze, I apologize. Goodness gracious. Okay, so this 5 here means that my graph is getting narrower. If I move over here to number 2, this 2/3 is less than 1, so that means that my graph is getting wider than the original graph. If you have a number, remember that your numbers to the left of the x determine the width of your parabola. So because this is inside of my parentheses, but to the left of x, this is still determining width. This 3 on the inside still makes my graph narrower. It's not as narrow as when I had a 5 out here. That 5 out there was super narrow, but this 3 does make my graph narrower than the original. This 1/4 is making my graph wider. And if you're never sure, you can always plug these things into Desmos and let your calculator do it for you. Okay, so here we have a bunch of examples of transformations that are happening. I'm going to skip the first couple of ones, and I'm mainly going to look at number 10 and 11. The other ones you should try on your own, and then you can check to see if you got the same thing that I did. But until then, for now, I would just check to see if you can do numbers 10 and 11. So if you want to try this one on your own first, I would just pause the video here, and then you can unpause it when you're done attempting it to see if you got the same thing. So this one does have 2 transformations. The first one is this 1/5, and because it is to the left of x, we know that that's going to affect the width of our parabola. 1/5 is smaller than 1, so our graph is going to be wider. And then you have this -3 back here. It is to the right of x, which means that it's going to change it's going to translate my graph up, down, left, right. So that -3, it's not in parentheses. That just means that I am going down 3. All right, and then again, if you want to check, I will let you pause the video here, and then you can double check when you're done to see if you got the same thing that I got. So if you want to pause it, now would be the time to do that. Okay, this one has 3 options for the transformations that are occurring. Sorry, my brain just stopped working for a second. Okay, so here's my x. Anything to the left of x determines width. That is 5/3, and even though it is a fraction, 5/3 is actually a number that is larger than 1, so this is going to make my graph wider. Then I have this -4 in the parentheses, but it is to the right of x, which means that that's going to affect right or left. And because it is inside of the parentheses, this is going to be a right 4. And then last we have is a down 1. And then again, if you would like to try these other ones just to see if you got them right, the completed notes will be available to you. But that's really all that is for this video, because it's not really any different than your linear transformations. If you have any questions, make sure to go see your teacher during their normally scheduled tutorial times, and I will see you in the next video. Bye.